So in this example, we're going to be doing prime factorization. It says determine the prime factorization of the number 3150. And we're going to use a factor tree to do that. A factor tree is just a way of branching off from a number to show all the factors of that number. But a couple of things I want to point out here. A prime number. A prime number is a number that has only two factors, and that's 1 and itself. Other than that, a number is a composite number, and a composite number can be broken down into a series of prime numbers. Now, the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and 23. These are the first 10 prime numbers. And as you notice, all of these numbers are odd except for the first one here, number 2. That's the only even prime number. And it makes them prime because the only factors for 2 are 1 and 2. The only factors for 3 are 1 and 3. The only factors of 5, 1 times 5, 1 times 7, etc. So we're going to make a factor tree. We're going to take 3,150, and we just branch off and determine what the first prime number is. And I'm going to start with 2. I can see that 3,150 is an even number. So that's 2, and then we do another branch here. That's 2 times 1,575. 2 times 1,575, that's 3,150, but this is not prime. So we branch off again. That's going to be 3 times 525. Again, 525 is not prime, so we branch again. And we keep branching until we have all the primes. And then finally, 5 times 7. So you can see right here, these are the prime factors of 3,150. That's 2 times 3 times 3 times 5 times 5 times 7. 2 times 3 times 3 times 5 times 5 times 7. That's equal to 3,150. And we're going to write this as 2 times 3 squared times 5 squared times 7. Now, a lot of times you may not see 2. I like to do, this is just particular to me, I always like to start with the smallest prime. So if I know a number is even, right away I'm going to use 2. But a lot of times students will see something else. A lot of them will see a 5 in there since it ends in a 0. So you can use 5. You don't have to start with 2. That's just a personal preference for me, but you could start with 5. So that's 5 times 630. Students will see a 0 again, and then they'll want to take out a 5, which is fine. You can do that. Like I say, it's just a personal preference for me to do it from the smallest prime to the largest prime that's built inside this this number. So now it's even. So here's 2 times 63. Here's 3 times 21. And then 3 times 7. So we still have all the same primes. We just found them in a different order. So it doesn't really matter which one you start with as long as you get them all and you keep going until you can't find any more primes. Like I say, personally for me, I like to start off with the smallest, but you can start wherever it's convenient for you. But there we go.